All right, let's go ahead and get started. Today we're going to be doing the last 11 questions on the Algebra 2 SOL test for 2014. For number 39, it asked me to find a arithmetic sequence. So let's take a look at that. It says, what is the 14th term of an arithmetic sequence where the first term is 7 and the common difference is 10? So for the 14th term, what that means is we're trying to find A14. A14. So what that means is I'm going to change this n right here into a 14. And everywhere else I see a 14, I'm going to put that in for n. So this n is going to change into a 14. And now we just need to know what A1 is and what D is. Okay, so it tells me that the first term is 7. That's going to be my A1. So right here, I'm going to put a 7 where the A1 is. And then the common difference D is what we add each time to get to each new number. So what does it tell me D is in the problem? It tells me that D is 10. So I'm going to put 10 in parentheses right here. And now we just evaluate the formula. So I've got 7 plus 14 minus 1. We know that 14 minus 1 is going to give us 13. And I've still got this 10 inside parentheses right here. So now I can multiply these two numbers, 13 times 10, and get 130. So I'm going to bring down the 7 and multiply these two numbers to get 130. And then 7 plus 130 is 137. And that's going to be my answer. So for this question, we're starting off with a 7, but then we're adding 10 each time. So 7 plus 10 is going to give me 17. And then 17 plus 10 is going to give me 27. And then 37. And then 47. And we keep on going until we get to 137. That's the 14th term in the sequence. So if this is the first term, second term, third term, fourth term, then you can tell that the 14th term is going to be 137. Okay, let's look at number 40. For number 40, it says that it has a function g, is shown in this graph right here. And what I want to do now is I want to find the inverse of g. So the function g of x has ordered pairs, and I want to choose 2 of the ordered pairs. So looking at the graph that I have right here, what are my ordered pairs that I can choose? Well, I can choose this dot right here. That would be the point 4, 0. And I need another point. Let's choose the Y-intercept right here. The Y-intercept is going to be this point right here on the Y-axis, 0, 2. So if we know these two ordered pairs, then the inverse function, g inverse of x, has inverse ordered pairs. So what we're going to do is we're going to take those 2 points that we just found and we're going to flip them. so that the x value becomes the y value and the y value becomes the x value. So if I was to switch up 4, 0, I would get 0, 4. And if I was to switch up the next point, I wouldn't have 0, 2 anymore. I would have 2, 0. So now I'm looking for the graph that has these 2 points right here. This one and this one. So when you're looking at your answer choices, you're trying to find the graph that has these 2 ordered pairs. So which one has 2, 0? You could either choose C or D. But to choose between these, we would need to know the second ordered pair, and that was 0, 4. So which one has the point 0, 4? It would be C. It has that y-intercept of 4 up here, and then down here it has an x-intercept of 2. So the inverse of G is going to be the graph C. Okay, let's look at 41. 41 gives me a function h of x. Let's go ahead and write it down. (41) gives me the function h of x is equal to x cubed plus 3x squared minus 4x minus 12, I think. Yeah. Okay. So it gives me this function, and it asks me to find the x-intercepts and the y-intercepts. So in order to find the x-intercepts, what we need to do is we need to take the entire function and set it equal to 0. So we're going to set h of x equal to 0. And when I do that, I'm going to take this entire function right here and set it equal to 0. And then we're going to solve it for x. Okay, so now we've set it equal to 0, and I need to start factoring. What I'm going to do is I'm going to group the first 2 terms and the last 2 terms together. So in my first group right here, I see that they have 2 x's in common. I can take out x squared. But then when I do that, I'm going to be left with x plus 3. Over here in this group, I notice that they have a negative number in common. They have a negative 4 in common, right? So I can take out a negative 4. And when I do that, I'm left with x plus 3. So now, notice that the inside parts are going to match up. This x plus 3 and this x plus 3. So now what I can do is I can put the outside parts together in their own set of parentheses. I'll have x squared minus 4. And then I'm going to take the inside parts, let them have their own parentheses. And now it's factored. So I get x squared minus 4 and x plus 3. So now what I'm going to do is I'm going to set both of these equal to 0. If I set the x plus 3 equal to 0 and I solve that, I need to subtract 3 from both sides, and I get x is 0 minus 3, and that's going to be negative 3. So that's my first x-intercept. And now what I can do is I can set the other factor equal to 0. Let's see what happens when we do that. So now I have x squared minus 4 equals 0. I can break this down into difference of squares. I'm going to get x minus 2 and x plus 2. And they're both equal to 0. So for the first factor, that's going to give me x equals positive 2 if I set it equal to 0 and solve it. And then this factor is going to give me x equals negative 2. So those are going to be my x-intercepts. 2, negative 2, negative 3. Okay, so then I have to take all those numbers, put them where the x values match up with those numbers, and you're going to have this first order pair up here, this second one down here, and then you're going to have 2, 0 down here. Those are the x-intercepts. Now let's go ahead and find the y-intercepts, and I'll do that on the next slide. So my function is x cubed plus 3x squared minus 4x minus 12. So this time I want to find the y-intercepts. For the y-intercepts, I have to let x equal 0. So we're just going to let x be 0 and see what happens. When I do that, this x on the inside of this parentheses is going to change into a 0. And then everywhere I see an x, I'm going to let it be 0. So I get 0 cubed plus 3 times 0 squared minus 4 times 0 minus 12. Now, the good thing about this is you have a bunch of zeros, and that's going to cause most of these terms to cancel out. 0 cubed is going to be 0. 0 squared is going to be 0. And if you multiply that by 3, you're also going to get 0. So I can cross that out. 4 times 0 is 0. So I don't have to worry about that one. So then my answer is going to be negative 12. That's my y-intercept. So if I want to write this as an ordered pair, my x value would be 0, and I'm getting that from here. And then my y value is going to be negative 12, that number that we just found. So that is the y-intercept. Now, another way you can do this, you can graph it, right? So if I was to graph it, I would just type it in the way that I see it. H of x equals x cubed plus 4x squared minus 3x minus 12. So here's our graph. Yeah, that should be a 3x squared. And then this should be a 4. There we go. So now, what are my x-intercepts? Right here, negative 3. Here, I have negative 2. Here, I have positive 2. So those are the x values. That's where the graph is going to cross the x-axis. But where does it cross the y-axis? I'm going to have to zoom out to see that. And that is right here, negative 12. So that's the y-intercept. You have to let x be 0. So if you're ever finding intercepts, you're always letting the opposite variable equal 0. So for the y-intercept, you let x be 0, but when we found the x-intercepts, you needed to let y be 0. So this is essentially the same as letting y be 0. Let's look at 42. 42 says, which of the following describes the end behavior of this function as x approaches positive infinity or negative infinity? So let's write down this function. Y equals negative x squared plus bx plus c. I think that's it. Yeah. Okay. So we want to find out what happens as x approaches negative infinity and as x approaches positive infinity. So the way this function is going to look is I'm going to do a quick graph of it right here. This will be my x-axis and this will be my y-axis. If I was to graph this, we know that the highest exponent is going to be 2. So the graph is going to have a U shape to it. Now, the graph is going to open upside down, and that's because the leading coefficient up here is negative. There's a -1 in front of this x squared. So my graph is going to look somewhat like this. It's going to have an upside down U shape. So now, what happens as x approaches negative infinity? That means you're moving to the left. That means you're moving to the left. So as you go to the left, what's happening to the function? It's going down, right? It's going down. And it's going to go all the way down to negative infinity on the y-axis. But what happens as x goes to the right? What happens as x goes to the right? That means we're going to follow the function as it moves to the right. So as the function goes to the right, what is it doing? It's also going down, right? So I can say the function is going down. That means that y is going to approach negative infinity. So on both sides, the function is going downwards. So then the answer would be B. Y approaches negative infinity. And that's what we wrote right here and here. Now let's take a look at it on Desmos. I'm going to graph it exactly as I see it in the question. So I'm going to type in y equals negative x squared plus bx plus c. And it's asking me to add sliders. So I'm going to choose all. Okay. So now the function is going to show up in red, and the function looks like an upside down U shape. So as the function goes to the left, it's going down on the y-axis. And as the function goes to the right, it's also going down on the y-axis. And that's called the function's end behavior. So end behavior means what's happening as the function goes to the left and as it goes to the right. Okay, let's look at 43. So 43 is going to give us two different functions, and I'm going to write them both down. So it tells me f of x is equal to 2/3 x squared plus 1. And it tells me g of x is 6x minus 15. And it's telling me to find g of f of x. So what I want to do is I want to take the function f of x and put it inside of g of x. What that means is everywhere I see an x in g, I'm going to put in the function f of x. So I'm going to take this entire function and put it right here. That's called a function composition. So let's start off with g of x. We're going to start off with a 6. Next to it, I'm going to put the entire function f of x, which is 2/3 x squared plus 1. Close it up, and then we're going to subtract 15 at the end. So let's see what happens to this function. I need to multiply everything on the inside by 6. When I do that, 6 times 2/3 is going to give me 4 x squared plus 6 times 1 is going to give me 6. And then I'm subtracting 15 at the end. So now the last thing that I need to do is combine my like terms, 6 and negative 15. 6 minus 15 is negative 9. So I'm going to get 4x squared minus 9. That's going to be my new function. Okay, so is there an answer choice that matches up? It's going to be B, 4x squared minus 9. Okay, let's look at 44. Is going to give us a function, and it asks for the domain. So let's write this function down first. F of x is going to be equal to x plus 3. And everything is going to be divided by the denominator, which is x squared plus 5x minus 24. So this is my function, and it asked me to find the domain. What is the domain of this function? So remember that the domain is the set of all x values, all the x values. So really, x can be any number it wants, but there's going to be some restrictions, right? First of all, you can't divide by 0. So anything that would make the denominator equal to 0 is not good. So let's go ahead and factor this and see what we get. Now, I'm still going to have x plus 3 at the top. That doesn't change. On the bottom, I have x squared plus 5x minus 24. I can factor this. So to multiply to negative 24, I'm going to need 8 and 3. 8 times 3 is 24. That's good. But one of these numbers has to be negative. And the way I figured that out is I also have to consider what I'm adding to. I'm adding to this positive 5 right here. And what that means is the smallest number, 3, has to be negative. So then I can factor this as x plus 8 and x minus 3. So that's going to be my denominator. Now, I can't let the denominator be 0. So I need to set both of these factors equal to 0. So x plus 8 is equal to 0. And x minus 3 is equal to 0. So now solving them both for x, I need to subtract 8 on both sides. I get x equals negative 8. And then over here, I can add 3 to both sides. 0 plus 3 is 3. So these are the two answers that I get. Negative 8 and positive 3. Those are the two numbers that x cannot be. Because what if x really was 3? Then I would get 3 minus 3 right here, and I'd be dividing by 0, and that's not good. So x cannot be 3, x cannot be negative 8. So the domain is going to be all real numbers except for these two. All real numbers except negative 8 and 3. Yep, that's going to be B. So the only reason why x can't be those two numbers is because you'd be dividing by 0. Okay, let's look at 45. .45 is a variation problem. It says the amount of work, W. So I'm going to have W equals varies jointly. So variation is going to require a K somewhere. Usually it's on top. So I'll just put W equals K. It's going to vary jointly with the mass of the object, which is M, and the distance that the object is lifted, D. So what that means is joint variation means that you're multiplying everything together. So I need to multiply M times D. So I'm going to do M times D. So far I have KMD. What else does it say? Which equation models this relationship? The only one that matches up is going to be C. W equals KMD. And when you're multiplying everything together and you have 2 or more variables, that is called joint variation. Let's look at 46. So 46 says, Madison deposited $1,000 into a savings account that compounds yearly. She did not withdraw or deposit any money from this account, and the table below shows the amount in her savings account. So over here on the left side, these are going to be all the X values. Number of years after the deposit, 2, 4, 6, 8, 10. Those are all the X values. And then all the Y values are going to be on the right side. This is going to be the amount in savings. And then it asks, using the exponential curve of best fit, What is the closest expected amount 30 years after? So what we're going to do is we're going to do an exponential regression. So I'm going to go to Desmos, get rid of everything, and I want to start a table. So I go up here to the plus button and I hit table. And what I'm going to do is I'm going to put all the X values on the left side. That's going to be 2, 4, 6, 8, 10. And then for the Y values, I have 1123.6. And then 1262.48. And then 1418.52. Beside the 8, I have 1593.85. And then beside the 10, I have 1790.85. Okay, so now I have all my numbers in. What I'm going to do next is I'm going to hit the zoom fit button so I can see all the points. There they are. And now we're going to do an exponential regression. So I'm going to need Y1, squiggle, and then I'm going to have A, B. And I'm going to raise the B to the X1 power. So then that purple line is going to be my curve of best fit. I'm going to plot the residuals next. I'm going to hit zoom fit so I can see them. And then what I'm going to do is I'm going to write down my parameters down here. My A is 1000 and my B is 1.06. So down here in box 3, I'm going to have f of x is equal to 1000. And then in parentheses, I'm going to put my B value, 1.06, close it up, and then I'm going to raise it to the X power. And now the green curve is going to represent my curve of best fit. So now the question asks me, what if X is 30? What if after 30 years? What would the total amount be? So I'm going to let X be 30. So going back to Desmos, I'm going to let X be 30. F of 30 is 5743.49. 5743. That's going to be C. Okay, let's look at 47. Which graph best represents a function with zeros of -2, -1, and 2? So the zeros is the same thing as saying X-intercepts. So the question is really asking which graph has X-intercepts of -2, -1, and 2. So looking at the graph, I see that graph D is going to cross the x-axis at -2, -1, and +2. Everywhere else, the numbers don't match up, so I'm going to choose D. That's the only graph that has all of those x-intercepts. All right, let's look at 48. The number of permutations of 8 objects taken 3 at a time is what? So our total number of objects is going to be 8. And then we're using a permutation, so I'm going to use a capital P. And then how many are we taking at a time? 3. So we have 8 total objects. We're taking them 3 at a time. So we're going to use the permutation formula for this one. The first thing that I'm going to do is I'm going to put 8 factorial at the top. That's going to be my numerator. That's my total number of objects. And then in the denominator, I'm going to have 8 minus 3 factorial. So now what I'm going to do is I'm going to subtract 8 minus 3. That's going to give you 5 factorial at the bottom. And now I can simplify the top a little bit. We know that 8 factorial is going to be 8 times 7 times 6 times 5. And I'm going to stop at 5 factorial because that's going to cancel out with the 5 factorial in the denominator.
Coach, don't forget to go back.
Okay. So the 5 factorials are going to cancel out. We have 8 times 7 times 6. So I'm going to do 8 times 7 times 6. And that is 336. 336. That's going to be answer choice D. Okay. So you two, I want you to go down to the cafeteria, grab your food, and come on back. And I'll wait for you to get back. Okay. Let's do 49. (49) says if y varies inversely as the square root of x, then what is the constant of proportionality if y equals 16 and x equals 4? So inverse variation is going to require a fraction. And I'm going to have k at the top. And since it varies inversely with the square root of x, I'm going to put square root of x on the bottom. So that's my equation. And then it says y is 16, x equals 4. Y is 16, x equals 4. So basically I have this. Now what I can do is I can take the square root of 4. That's going to be 2. And now to get k by itself, I can multiply both sides by 2. So multiply the left side by 2, multiply the right side by 2. The 2's are going to cancel out, leaving me with a k is equal to 16 times 2. That's going to be 32. That's going to be C. All right, last one is 50. 50 says, which of the following describes the roots of the equation 9x squared equals 6x minus 1? 9x squared equals 6x minus 1. So the first thing that I'm going to do is get everything on the left side. So I need to subtract 6x from both sides, and I need to add 1 to both sides. So when I do that, everything on the right side is going to cancel out, leaving me with 0. And then on the left side, I'm going to have 9x squared minus 6x plus 1. Now at this point, I can do two things. I can graph it, which I'm going to do first, or you can use the quadratic formula. Quadratic formula. We'll do both. So when I graph it, I have 9x squared. 9x squared minus 6x plus 1. I think that's it. Yep. So now, how many roots does it have? Well, if I zoom in on it, how many times does it cross the x-axis? Just once, at 0.3 repeating. So that's going to be 1/3. So x is going to be 1/3. And since it only crosses once, that means that it has exactly 1 real root. Exactly 1 real root. And if you were to actually factor this, you would get 3x minus 1 times 3x minus 1. And then if you set this equal to 0, you would get 1/3. So exactly 1 real root, that's going to be A.